Albert Einstein's research methodology is renowned for its blend of deep physical intuition, rigorous mathematical analysis, and imaginative thought experiments. He challenged conventional wisdom and often questioned the foundational principles of physics, setting a new standard for scientific inquiry. How did he accomplish such revolutionary insights? By combining creative imagination with strict logical reasoning, Einstein developed theories that reshaped our understanding of space, time, and energy. One of Einstein's most distinctive approaches was his use of thought experiments. Instead of relying solely on experimental data, which in his time was often limited, he used mental simulations to explore the consequences of theoretical ideas. For instance, to develop the theory of special relativity, Einstein imagined riding alongside a beam of light. This exercise led him to realize that the speed of light must be constant for all observers, fundamentally challenging the notions of absolute time and space. Such thought experiments allowed him to test and refine his hypotheses before any laboratory measurements could be made. Einstein also placed great emphasis on mathematical elegance and simplicity. He believed that the laws of nature should be expressed in clear, concise equations. His use of symmetry and invariance principles, key tools in mathematics, helped him construct theories that not only explained known phenomena, but also predicted new ones. For example, his famous equation E equals mc2 emerged from a careful analysis of how energy and mass are interrelated, unifying concepts that were previously considered separate. Why is mathematical simplicity so valuable? Because it often reflects the underlying unity of physical laws, allowing complex phenomena to be understood through a few fundamental principles. Another important aspect of his methodology was the willingness to challenge established theories. Einstein did not accept traditional ideas at face value. He critically evaluated them and, when necessary, discarded or modified them to better fit observed phenomena. This was evident in his rethinking of Newtonian mechanics. While Newton's laws had been immensely successful, Einstein's insights into the nature of light and motion revealed limitations in the classical framework, especially at very high speeds. How can questioning established knowledge lead to progress? By confronting and resolving the contradictions between theory and observation, new, more comprehensive theories can emerge. Einstein's approach was iterative and self-correcting. He would refine his theories over time, incorporating feedback from both experimental findings and critiques from his peers. His readiness to revise his ideas even after they were widely accepted underscores the importance of flexibility in scientific research. This continual process of hypothesis, critical examination, and revision is a hallmark of a robust scientific methodology. In essence, Einstein's research methodology combined imaginative thought experiments, mathematical clarity, and a relentless drive to question and improve existing theories. His ability to visualize complex scenarios and translate them into simple yet profound mathematical statements has inspired countless scientists to adopt a similar approach. Could this blend of creativity and critical analysis be the key to unlocking the next scientific revolution? The enduring impact of Einstein's work suggests that fostering a balance between innovative thinking and rigorous testing remains central to the advancement of science. Einstein's research methodology was characterized by a deep reliance on thought experiments and conceptual analysis, rather than solely on empirical data. He believed in questioning established ideas and reimagining fundamental principles to explain natural phenomena, and his approach combined rigorous mathematical reasoning with intuitive insights into the workings of the universe. This method allowed him to develop groundbreaking theories that reshaped modern physics. For example, Einstein's development of the theory of special relativity was largely driven by his famous thought experiment about chasing a beam of light. It's like using your imagination to visualize a complex puzzle before assembling the pieces. By picturing the whole picture, you can identify the key elements needed for a solution. Einstein extensively used thought experiments to explore and challenge the limits of established scientific concepts, as these mental simulations allowed him to test hypotheses in a controlled, imaginative environment without the need for physical experiments. He often used these experiments to isolate critical variables and understand how they interact in extreme conditions, a practice that was central to his development of theories that defied conventional wisdom. For example, Einstein's thought experiment of riding alongside a light beam enabled him to question the nature of time and space, laying the groundwork for his theory of special relativity. It's like solving a complex problem in your head before writing anything down. This mental rehearsal helps you see potential solutions clearly. Einstein was known for seeking simplicity and elegance in his theories, believing that the simplest explanation was often the correct one, and he aimed to strip away unnecessary complexity to reveal the fundamental truths of nature. His work demonstrates that profound insights can emerge from straightforward, clear formulations, a pursuit that continues to inspire scientists to refine and streamline complex theories. For example, the elegant equation E equals m times c squared encapsulates a deep relationship between energy and mass in a remarkably simple form. It's like finding that a simple key unlocks a complex lock. Sometimes the most straightforward solution is the most effective. Einstein seamlessly integrated mathematical rigor with physical intuition, using advanced mathematics to express his imaginative ideas about the universe, and he viewed mathematics as the language of nature, essential for articulating complex physical concepts. This integration allowed him to develop models that were both conceptually innovative and quantitatively precise, effectively bridging the gap between abstract thought and observable phenomena. For example, Einstein used tensor calculus to formulate the equations of general relativity, linking the curvature of spacetime with the distribution of mass and energy. It's like using a precise set of blueprints to design a building. The mathematical details ensure that the visionary design becomes a practical, stable structure. Einstein's approach involved a constant re-examination of accepted scientific doctrines and assumptions, as he was not afraid to question prevailing theories and explore alternative perspectives, a willingness that often led to paradigm shifts. This method allowed him to uncover inconsistencies and gaps in existing models, teaching that progress in science frequently begins by doubting what is taken for granted. For example, by challenging the Newtonian concepts of absolute time and space, Einstein revolutionized our understanding of the universe with his theories of relativity. It's like questioning an old family recipe that everyone assumes is perfect. By challenging its ingredients, you might discover a better version that enhances the final dish. Einstein's research process was iterative, involving continuous refinement of ideas through persistent questioning and recalibration, as he often revisited and reworked his theories to address new evidence and resolve emerging inconsistencies. This persistent approach ensured that his final models were robust and resilient to criticism, demonstrating that true scientific breakthroughs require time, effort, and constant reevaluation. For example, Einstein spent years refining his general theory of relativity, repeatedly modifying his equations until they accurately described gravitational phenomena. It's like sculpting a statue from a block of marble. Each chip and revision brings you closer to a refined, finished work of art. Einstein frequently employed analogies and conceptual models to simplify and communicate complex ideas, as these analogies served as bridges between abstract theory and everyday experience, making his work more accessible. They allowed him to clarify intricate concepts and test the consistency of his ideas in a familiar context, a practice that remains a powerful tool in both teaching and scientific innovation. For example, Einstein's comparison of gravity to the curvature of a stretched rubber sheet helped illustrate how mass can distort spacetime. It's like using a stretched fabric to explain how a heavy ball placed on it creates a dip. This visual model makes a complicated concept easier to understand. Einstein's methodology was not confined to physics alone. He drew insights from philosophy, mathematics, and even art to inform his scientific work, and his interdisciplinary approach allowed him to see connections between different fields that others might overlook. Collaboration and cross-disciplinary thinking enriched his ideas and led to comprehensive theories that addressed multiple facets of natural phenomena, a broad perspective that is a key element in his legacy of innovative problem-solving. For example, Einstein's work on relativity was influenced by his philosophical reflections on time and space, which helped him conceptualize a new framework for understanding gravity. It's like combining ingredients from different cuisines to create a fusion dish. Each element contributes to a richer, more nuanced final product. Einstein's research methodology has had a profound and lasting impact on modern scientific inquiry, influencing how new theories are developed and tested, as his emphasis on thought experiments, simplicity, and the integration of diverse ideas continues to inspire scientists worldwide. His rigorous yet creative approach serves as a model for tackling complex problems in various fields, demonstrating that a blend of critical thinking, persistence, and imagination is essential for groundbreaking discoveries. For example, modern researchers continue to use thought experiments and conceptual models in fields ranging from quantum mechanics to cosmology, echoing Einstein's approach to science. It's like following a time-tested recipe that has been refined over generations. Each new cook builds on the wisdom of the past to create innovative, delicious results.